Right, good morning or good afternoon and welcome to lesson 27 of module 4, topic D. Today we're going to be continuing with standards 8, EE6, and EE8B, where we're solving two systems of linear equations through graphing and estimating those solutions. Okay. By the end of the lesson, you'll be able to determine the solution to a system of equations by graphing. You'll know you're successful when you can use the slope and y-intercept to determine if it has one solution, no solution, or infinite solutions. And like always, we're going to go through review, examples, exercises, closure, and an exit ticket. All right, so just to build some background, we're going to be using this graphic throughout the lesson today, so you will get used to it. It says we can determine how many solutions a system of equations has just by looking at the slopes and the y-intercepts. So if we look at our M and our B, we can tell, hey, this has one solution, hey, this has no solution, hey, this has infinite solutions. And here's how we do that. So if there are different slopes, there is only one solution. So that's the first thing you should look at. If the m's are different, oh, well this equation has one solution. Okay? Now if they have the same slopes, but they have different y-intercepts, then there's going to be no solution because those lines are going to be parallel. Same slope, right? But different y-intercept. They're going at the same rate, but they're at different parts on our graph. And lastly, if they have the same slopes and same y-intercepts, that's the same equation. And so those lines are going to overlap and there's going to be infinite solutions. So this is our new work for today. We're going to just be looking at M and B and seeing which one of these types of solutions does our system fall under. All right, for example 1, we want to determine the nature of the solution. We don't need to graph this. We just need to look at our M and our B. So we need our equations to follow y equals mx plus b format. If I'm looking at my equations, this first one does not. So I'm going to have to rearrange that down here. So I'm just going to rewrite it and then draw a line through my sign. Remember, I'm trying to get it so it says y equals, so I need the y to be by itself. Right now, this y is not by itself. It's got a couple things going on. The first thing I see that's going on is it's being added to 3x, and then it's being multiplied by 4. So I'm going to get rid of my 3x first. So I'm going to take away 3x from both sides. Over here it cancels and I'm left with 4y's equals, well I want it to say y equals mx, so I'm going to have my x's first, so mx plus b, and what was the other number I'm adding? 5. Okay? From there, there's still a coefficient with my variable y, and I want it by itself completely, so I'm going to divide by 4 on both sides. Over here it cancels and I'm just left with y equals. Over here I got to do this twice. First one is negative 3/4 x. The second one is 5/4. So now I have my equation y equals mx plus b. Real quick, I'm just going to rewrite my system. So that was my first equation, and the second equation they gave me, it's already written in the correct format. It's written in y equals mx plus b, so I'm just going to copy it down here so I can see it. And it is y equals negative 3/4 x plus 1. So this is my system, but I'm not done here. I just needed to get it in slope-intercept form so I can determine how many solutions does this have. Is it going to have one solution? Are these lines going to cross? No solution? Are they going to be parallel? Or infinite solutions? Are they the same line? Well, let's look at our purple box. Do they have different slopes? So let's look at their slopes, their m's. No, they don't have different slopes, so it's not one solution. Okay? So they have the same slopes. Do they have different y-intercepts? Well, this one is an intercept of 5/4. This one is an intercept of 1. So yes, they have different y-intercepts. So what does this mean? This means these lines are parallel. There's no solution. And that is what we're going to be doing today. Please make sure you have everything down for example number 1. All right, example number 2, we're going to do the same thing. The first thing we need to do is make sure we're in y equals mx plus b format. And we are not for this first one, so I'm going to go ahead and change that. 7x plus 2y equals negative 4. I want my y by itself. Right now there's 7x being added, 2y being multiplied, so I'm going to subtract the 7x's first. I end up getting 2y equals negative 7x's and a negative 4. From there, I need to get my y completely by itself. Right now it's being multiplied by 2, so I will divide by 2 on both sides. What I end up getting is y equals negative 7 over 2x plus negative 4 divided by 2 is just going to be negative 2. All right, so that's my first one. Now I'm going to look at my second equation, not in slope-intercept form, so I got to change it. We have x take away y equals 5. All right, so the first thing I need to do is get rid of that minus sign, so this becomes x plus negative y equals 5. I'm trying to get my y by itself, so I'm going to take away that's going on, and it's also being multiplied by a negative 1. The 1 is invisible. So I got to get rid of both of those things. So I'm going to take away 1x from both sides. I'm left with negative 1y equals negative x plus 5, and you can put a 1 there if you want. From there, I got to get y by itself, so I divide by my coefficient of negative 1. And I'm left with y equals, well, what's negative 1 divided by negative 1? Positive 1. What's 5 divided by negative 1? Negative 5. So these are my two equations. I'm going to write them as a system here. Y equals negative 7 over 2x plus negative 2. And my second one was y equals 1x plus negative 5. So I'm going to check it with my little boxes up here. So looking at my purple box, so they have different slopes. This one's slope is negative 7 over 2. This one's slope is 1. So yes, they have different slopes. Oh, that was pretty quick and easy. What does that mean? That means they have one solution, because they have different slopes. That's the only option if there's different slopes. It's just, okay, well, they're going to cross sometime. Moving on. All right, example number 3. I can already see that these are not in slope-intercept form, so I'm going to have to change them. So starting with the first one, I have 9x plus 6y equals 3. My second one is 3x plus 2y equals 1. And I'm trying to write these where y is by itself. I'm going to quickly do my math here. Take away 9x from both sides. 6y equals negative 9x plus 3. Divide both sides by 6. Cancels, I'm left with y equals negative 9 over 6 reduces. You could leave it as negative 9 over 6 if you want, but I'm going to just reduce it so it becomes negative 3 over 2. And 3 over 6 does reduce as well. That's just 1/2. Okay, so I got my first one down. Second one, I'm going to take away 3x from both sides. I'm left with 2y equals negative 3x plus 1. Oops. From there, I'm going to divide by 2 on both sides. I get y equals negative 3 over 2x plus 1/2. What do you notice about these? Take a second. What do you notice about them? Look at their slopes, look at their y-intercepts. Well, if you look at their y-intercepts and their slopes, you'll notice they're the exact same slope. So it's not that. Same slopes, different y-intercepts. Same y-intercepts. So what does this mean? This is the same line. Infinite solutions. Because it's the same line. It's overlapping. Okay, and we're done with example 3. All right, just to reiterate our new learning for today, we can look at our equations when our system is written in slope-intercept form, and we can just tell, okay, are these lines going to cross? Are they never going to cross? Or are they overlapping? Are they having one solution, no solution, or infinite solutions? So that is what we're doing today. The extra part of today is just remembering how to transform an equation that's in standard form to slope-intercept form. But that's just some algebraic, mathematical, computational work that you just have to be down with. So we're going to practice that today. All right, for your first exercise, please turn both of these equations into slope-intercept form. And then tell me, do they have one solution, no solution, or infinite solutions by looking at their slopes and y-intercepts. I'm going to give you a couple minutes to do this before I show you my work and we go over it. All right, so you'll see my work just kind of appeared. So I did my math, rearranged my equations so that they followed y equals mx plus b form. And these are the two equations I got. I went ahead and I wrote them in my system format. So I have y equals negative 1x plus negative 7 and y equals negative x plus negative 7. Now, one thing I do want you to note, this is a negative 1. So looking at those, they are the exact same equations. So what you should have decided is that these are the same lines. They're overlapping, so they're infinite solutions. Okay, that is your answer here. Make sure you have this down before moving forward. Maybe if you made a mistake in your math, look for that mistake and see what I did differently, okay? Because I have all my work shown. All right, exercise 2, you'll see that your first equation is already written in slope-intercept form. It's your second one that you really need to change. So you're going to take this equation, change it to y equals mx plus b, and then tell me by looking at the slopes and y-intercept of this system, one solution, no solution, or infinite solutions. Take a couple minutes to work on this right now, and then come back and check your work. All right, you'll see right now that this first equation was already written in slope-intercept form, so I just added that to my system. The second one I had to change, but I did, and I added over here. Looking at these, do they have different slopes? Yes, they have different slopes. So what does that mean? There's going to be one solution. We don't even need to look at their y-intercepts because it doesn't really matter if they have the same y-intercepts. That is going to be where they cross. So they have one solution. You might have said, oh, well, they have the same y-intercept. What does that mean? That doesn't mean anything. That only means something when you have the same slope as well. So we always want to look for our slope first. But this has one solution because they have different slopes. Okay, check your work with my work, check your math with my math, make sure you didn't make any mistakes, and if you did, correct them and look out for them when we move forward. All right, just to close out this lesson, we need our equations to be written in slope-intercept form, and when they are, we can compare our slopes and our y-intercepts to determine if they have one solution, no solution, or infinite solutions. If they have different slopes, they automatically have one solution. If they have the same slopes but different y-intercepts, they have no solution. And if they have the same slopes and same y-intercepts, that's the same line. They're just overlapping. That is infinite solutions. Okay? Before we move on to the exit ticket, make sure you're confident. If you need to go back and rewatch some things, please do that. And then complete your exit ticket for your grade today. All right, here's your exit ticket. The first thing you're going to need to do is change your equations so that they follow y equals mx plus b format, okay? So you're going to need to move your y's over to the left side, and from there, you're going to need to get them completely by themselves. Once you've done that, create your system, and then look at your slopes, look at your y-intercepts and identify, do they have one solution, no solution, or infinite solutions to your system, okay? Take your time, show your work. I'll be in the chat. You can reach out to me if you need help or have questions. Good luck.